Okay, so get this, listeners. We're going to dive into a world where robots, get this, are controlled by mushrooms.
You heard that right, mushrooms.
I'm not talking about, like, your pizza toppings here. We're
No!
talking about actual living fungi being used to, like, power and control robots.
Mm.
You sent over some fascinating research from Cornell University about this, so let's dig in.
Yeah, absolutely. This is cutting-edge stuff in the field of biohybrid robotics,
Right.
where living organisms are being integrated into engineered systems.
Okay, so unpack that a bit for us.
Yeah.
What's the advantage of using something like a mushroom in a robot?
Well, I mean, think about it. Mushrooms are incredibly adaptable, right? They can thrive in all sorts of environments.
Yeah.
They're masters of utilizing available resources, and their structure, specifically the mycelium, those thread-like networks,
Right.
that's what makes them so intriguing for robotics.
So we're talking about using the mushroom's mycelium, not the part we see above ground.
Exactly. Yeah, the Cornell team focused on oyster mushrooms and their mycelia, which form these intricate networks, kind of like the roots of a plant.
Okay.
These networks can grow and branch in response to stimuli, and remarkably, they generate faint electrical signals.
Hmm. So instead of wires and circuits, it's like the mushroom's natural network is becoming part of the robot's control system.
You got it. The researchers at Cornell built two different types of robots to explore this. One with wheels and another that's soft-bodied with 5 legs.
Uh-huh.
And get this, both of them move and react due to the way the mushroom's mycelium grows and interacts with the robot's hardware.
Yeah.
Yeah, and that's where things get really, mind-bending. Imagine these mycelial networks acting as the robot's nervous system,
Okay.
sensing and responding to the environment.
So how did they actually connect a mushroom to a robot? Like, did they have tiny little soldering irons for those mycelial threads?
Not quite. The researchers essentially built a bridge between the living organism and the machine. They used electrodes, kind of like tiny sensors, to pick up those faint electrical signals the mycelium generate.
Okay, so they're like tapping into the mushroom's communication network, basically.
Yes, and then it's all about signal processing. Those raw signals from the mycelium are amplified and translated into a language the robot's hardware can understand. It's like giving the mushroom a way to, talk to the robot's control system.
Right, right.
Right.
So what does this, fungus-robot communication actually look like in action? What can these robots actually do?
Well, in the Cornell study, they focused on one of the mushroom's natural abilities, sensing light.
Okay.
Remember how I mentioned those mycelial networks can grow and branch in response to stimuli?
Yeah.
Light is a powerful stimulus for them.
You're saying the mushrooms themselves can detect light?
Precisely. So the researchers were able to leverage that sensitivity. By analyzing the electrical signals from the mycelium, they could determine how much light the robot was being exposed to. Then they programmed the robot to respond accordingly. So, for example, the wheeled robot could change direction based on light intensity, moving towards or away from the light source.
Wow. That's incredible. So the mushroom is acting like the robot's eyes, in a way.
A very simplified way to think about it, but essentially, yes. And here's the really exciting part. They were able to get the wheeled robot to operate completely untethered.
What?
No external power source, just the mushroom's natural responses driving its movement. That's a big hurdle overcome in biohybrid robotics.
Untethered and
Yeah.
powered by mushrooms. That's
Right.
that's wild.
It really opens up the possibilities, doesn't it? This Cornell study was like a proof of concept, but imagine the potential applications.
Yeah, that's what I'm most curious about, honestly. Like, where could this technology actually be used?
Well, let's start with agriculture. Imagine mushroom-equipped robots, right, roaming the fields,
Okay.
analyzing soil health in real time.
Okay, so instead of just blanket fertilizing a whole field,
Yeah.
you could have these robots detecting exactly what nutrients each area needs.
Exactly. Yeah, it could lead to more targeted and sustainable farming practices,
Right.
reducing waste and environmental impact.
Wow.
And not just agriculture. Think about environmental monitoring.
Okay, yeah.
Yeah.
Like
yeah.
robots that can detect pollutants in the air or water.
Precisely. Or robots deployed in disaster zones, right? Using their fungal senses to navigate through rubble and locate survivors, for example.
Wow.
The possibilities are vast.
Yeah, and because fungi are so adaptable, these robots could potentially operate in harsh environments where traditional robots might struggle.
Absolutely. Plus, there's ongoing research into other fungal biotechnologies. Scientists are even exploring the use of fungi to create, get this, Self-healing material.
Self-healing materials. Okay, so like robot skin that can repair itself if it gets damaged.
You're catching on. It's like something out of science fiction, but it's becoming a reality, and it all comes back to the unique properties of fungi, you know?
Yeah, it's incredible. So we've gone from robots controlled by mushrooms to potentially self-healing robots, all thanks to fungi. It makes you wonder what other, like, natural wonders are out there just waiting to be harnessed.
That's the beauty of scientific exploration, isn't it? There's so much we still don't know, and these discoveries often lead us down paths we could never have predicted.
Absolutely. Well, that definitely leaves us with a lot to ponder. So to our listeners, if you had a robot powered by a mushroom, what would you have it do? Food for thought as we wrap up this deep dive into the fascinating world of biohybrid robotics.